A long isolated wire coil is called a solenoid. The power supply source has been switched off and the compass needle points north. We switch on the power source and the needle turns in line with the coil's axis because a solenoid creates a magnetic field which is far greater than that of planet Earth. When we change the direction of the current flow, the needle turns its other end towards the coil. If we pass the compass through the coil, the needle keeps its direction. If we pass the compass around the solenoid, the needle points along the magnetic field lines. We have created the picture of magnetic field lines of a long solenoid using VisiMag software. The field is almost uniform inside the coil, while outside it looks exactly like the field of a permanent cylindrical magnet. Using VisiMag software, one is able to see not only the direction, but also the power of a magnetic field. The most powerful part of the field inside the solenoid is marked in red. The outer part of the field quickly gets weaker with the distance. To measure the field power on the solenoid's axis, we have installed a magnetic field sensor on a toothed rack. We insert the sensor into the solenoid. The magnetic field in the central part of the coil is 0.02 Tesla, which is 200 times the magnetic field of Earth. We remove the sensor from the coil and draw the graph. It can be seen that the magnetic field outside the solenoid gets weaker with the distance rather quickly. The magnetic field inside the long solenoid is proportional to the current intensity in the coil. It is also proportional to the winding density of the wraps. If there are twice as many wraps per coil length unit, the magnetic field also gets twice as powerful. In SI system, proportionality coefficient equals magnetic constant μ0. The output magnetic field on the axis of the long solenoid can also be easily calculated. Mentally, we add another identical solenoid on the other side. It creates an equal magnetic field in the marked point. But the two fields together equal field B, which means each of them equals half B. In our experiment, the solenoid was not too long compared with its diameter, and yet its output field is almost twice less intense than in its central part. Now the output field of the solenoid equals 11 thousandths of a Tesla. But it can be intensified by introducing a ferromagnetic core into the coil. The field has intensified by more than 4 times. Iron has got magnetized and strengthened the coil's magnetic field.